All right. So our first one to prove triangles similar is called AA similarity theorem. Okay. And this one states, if we have two angles of one triangle that are congruent to two angles of another triangle, then the triangles are similar. So one thing you need to know about similar figures, yes, they are the same shape. They are different sizes. Your angle measures will not change. Okay, so what that means is I can have a figure that's itty bitty like this. And this can be a 30, 60, 90 triangle. I can then blow this up and make it a big one, and it is still a 30, 60, 90 triangle. Okay. And these are still similar figures. So similar figures still have all of the same angle measures. Okay. So if you flip this open, we've got example 1 on the left. I'm going to fold this way. Make it easier. Okay. So they want to know here, are the two triangles similar? And if so, state how and write the similarity statement. So the way I do this, when they're put together, I like to pull them apart so I can compare them. So you've got one triangle, this little tiny one. Okay, this is XWB. And we know this is an 82-degree angle. That's this triangle right here. Okay. All I did was I took that triangle out and I pulled it out. So you can compare the two. So you've got that little tiny one, and then you've got this bigger one. And this triangle is XZY. And we know that this one is 82 degrees. Okay. So you see how I just pulled the two triangles out and made them two separate pictures instead of keeping them as one? Okay, so the theorem that we're looking at is angle. Well, right now, all we know is angle W is the same as angle Z. What else do you know, though? Even though they don't have it written, there's something else. There's two other angles that are congruent.
Y and B.
Cannot prove that.
I thought it was B.
What happens when I lay the two triangles on top of each other? It makes one big triangle, but what do they share in common? They are the same shape. What do they share in common, though? The what? No, somebody said it. The what? Say it louder.
X.
The X. Take a look. When I lay them on top of each other, this angle and this angle line right up. So even though we don't know the degree of the angle, we know that angle X and angle X are the same when I pull them apart. Because when I put them together, they match right on top of each other. Does that make sense? Okay, just like the triangles yesterday, they may have shared that line in common. This one shares an angle. Okay, so now that we know that, I can say triangle WXV is similar. So when we write similar, it's just the little wavy part of your congruent symbol. And we have to do the same thing that we did with congruence. If I go WXV, my second triangle has to be what? ZXY. I went from the 82 to the matching angle to the V. So I have to go from the 82 to the matching angle to the Y. So this is ZXY. And this is the AA similarity theorem. Okay, we just proved that with AA similarity. All right, take a look at example 2. Are the two triangles similar? If so, state how and write the similarity statement. This time they don't give you any angles. But what do we know?
They both share an H.
Good. What are those H's?
Vertical.
These are vertical angles. So you've got vertical angles there. So that's one set of angles. Remember, AA similarity, I need two. Just so you know, these little triangles here, if you forgot, mean that this line and this line are parallel. So these two lines are parallel.
So
G and what?
K.
What? What are they? She's saying G and K are the same. And I agree. But tell me why.
The opposite.
Opposite, which is alternate interior angles. Fantastic. Okay? Even though they don't tell you that they're the same, you can prove it from what you know from before. They're inside those parallel lines on the opposite side of your transversal. So now that you know that these two are the same, I can say that triangle KHJ is similar to triangle. I went KHJ, GHF. And again, this is angle similarity. Okay. With similarity, we also have one called SAS, which is side angle side. But this time, they're not proving congruent. This one says, in two triangles, if a pair of corresponding angles is congruent and the sides, including the angle, are proportional, then the triangles are similar. So this time, we don't want to prove that the sides are alike. They're not the same. They're going to be proportional. So we're going to do something called setting up a proportion. Anybody remember how to solve a proportion?
No.
So if I gave you something like this, do you even remember what a proportion is?
No.
Oh.
So if I give you something like this,
Oh yeah.
this is a proportion where you have a fraction equals a fraction. Do you remember how to solve this now?
Butterfly.
Butterfly method, or what we like to call nowadays cross multiply. So you would multiply 8 and 6, 48, and multiply 4 and 12, which again gives me 48. Fantastic. Boy, you're going to stress me out today. Okay, so with this concept, side angle side, the first thing I need is two pairs of congruent angles. Do I have that?
Yeah.
Yes. It's what? N and R. Fantastic. So angle N and angle R. Okay, please be very cautious because it said side angle side, which means the sides have to have the angle in between. Do my sides that I know have the angle in the middle?
Yeah.
Yes. So let's set up a proportion. So if I make this one 4/6, okay, pay attention. You've got the 4 at the bottom, the 6 on the side. When I set up my second one, it has to go that same way. So what number goes on top of my second triangle? 6. Good. 6/9. 6 is in the bottom, 9's on the top. Once you set that up, butterfly it and see if it works.
36.
Okay. Butterfly it and see if it works. So if I put the 6 on the top and the 9 on the bottom, when I butterfly, that gives me 6 times 6, which is what, Mr. Watkins?
36.
36. Mr. Watkins says 6 times 6 is 36. Fantastic. Mr. Meza, what's 4 and 9?
36, bro.
36.
Come
You
on,
have a
bro.
calculator. It's okay. 36. Does that equal? Yes. This is fantastic. So now you just told me, according to my pictures, I have two of the same angle and my sides are proportional. So guess what? The triangles are similar. Okay. So triangle. We're going to do, let's do LMN is similar to Marlin. Give me the new one. LMN. Take a look at your positions of where I pulled it from. LMN.
QPR.
Fantastic. So I went from top right to bottom left to bottom right. So he went top right to bottom left to bottom right. So this is triangle QPR. Question.
Bad.
Okay. You really need another what? What's wrong with you? It's falling out.
Yeah, it's gonna be forever.
I wish I sharpened this broken.
Oh, is it?
Yeah. I just bought that like 6 weeks ago and it's already broken. Okay. Are the two triangles similar? Remember, we're talking side, angle, side. So I must have an angle that is congruent to another angle. Good. Why L? Grace says L. Josue, why do you think Grace said L? Why do they share angle L in common?
Because that's what I hold.
Show me Josue. Show me Josue. Take a look at the two triangles. When they're put on top of each other, what matches up? L. Okay? When you're triangles, it's simple as that. When the triangles lay on top of each other, L matches up with L. Okay? Don't think too much into it. You guys get too panicked when you say math and you're like, oh, no, what, huh? You feel like you need to use some mathematical term. It doesn't always work that way. It's sometimes as simple as when you lay them on top of each other, they match. So, angle L is your congruent angle. Okay, this is why I said pull the triangles apart though. So, when I pull them apart, I've got this little triangle on the top that's LKM. And this side is a 6 and this side is a 10. When I pull the big triangle out though, this is LEJ. What is this side? It's not 3.
Oh, you gotta add both.
You got to add them. Okay? So this big triangle is this little piece and this piece from the original. So this is a 9 and this is a fantastic. So now set up your proportion. So this time, if I put 10 over 6, what does my second fraction look like? Fantastic. 15 over 9. Butterfly it and see if it works.
It's not.
Butterfly it and see if it works.
Ooh, yeah.
Yeah.
Yep. All right.
Hey, Elijah. Remember, I feel like
Awesome.
I yeah. I feel I got more energy than everybody out here, you know what I'm saying? Like, I feel like I can be
Yeah,
another trait, you know what I'm saying? So I can be another trait, you know what I'm saying?
Awesome.
I got that. All I got to do. Yes, ma'am. I got to.
Good.
It's
So when I butterfly this, I get what equals what?
90.
Fantastic. So 10 times 9 is 90. 6 times 15 is also 90. So that is proportional. So we are good. That is side angle side. Questions on that one? Okay. What everybody seems to get mixed up, though, is side angle side of similarity versus side angle side of congruence. So please be careful. Congruence means they have to be the same. Similar means they have to be proportional. Okay. Last theorem. Side, side, side similarity. This says if all three pairs of corresponding sides of two triangles are proportional, then the two triangles are similar. If you want to talk about work, this is the one you're going to have to show the most.
No.
No. So Juan's over there going, I hate work.
Huh?
Huh? Right.
Oh, yeah.
Okay. So you have to do 3 sets of proportions.
Oh, yeah.
Okay. Because you have to prove that side 1 is similar to side 2, side 2 is similar to 3, and 3 is similar to 1. You cannot just do one side and stop, because they may change up the numbers later on and they're not similar. So just because one comes out to be similar does not mean the other 2 relationships are. So here are your triangles. Okay. So again, this one's going to be the one with the most work, but it's the same steps like you did in the last one. So I need to set up my first proportion. 7 over 12. So I did 7 over 12. So Edwin, if I do 7 over 12, that means I have to do what with this one? Take a look at where 7's at and where 12's at and set up your fraction on the other side. Fantastic. 30 over 21.
The improper fraction.
Okay, it is an improper fraction. Ooh. They're pulling knowledge that I didn't know they remembered. Look at that. So when I cross multiply this time, what's 7 times 21?
Bruh.
Bruh, 147.
It doesn't
Okay.
work.
Yesy, what's 30 and 12?
Barely. Not at all.
Don't just assume it's 147 because that's what we got the first time. Multiply them. Come on.
Come on, bro. It's good.
360.
360.
I had no calculator, so I thought it was.
Awesome.
Wall. Oh, calculators.
You know how to count.
So Joseph has saved the day and said 30 times 12 is 360. Do these two match?
Oh.
No. Automatically not similar. Okay, so as soon as you find your first proportion that says no, that doesn't work, they're automatically not similar. So we can stop. Okay, these ones are not similar. Okay, flip it, last example. And then I'm going to show you how to solve.
No.
Yes! Solving is fun.
Math in general.
Okay, so this time they threw the triangles on top of each other again. So let's pull them apart and create our own triangles. So my first one is this teeny tiny one at the top, which is LKM. And my big one at the bottom is LDE. Okay, what is this side of my big triangle, L to D? 88. What about from L to E? We're looking at what, Christian? L to E is what? Fantastic. And Elijah, what's the bottom here from D to E? What's the measure of this bottom here from D to E? According to my original picture.
Oh.
121, good.
Oh,
He was confused with what I was asking. We all did. Okay, so now it tells me that K to M is what? 44.
40.
Okay. Let's see if Ureli's up to my challenge. Are you ready, friend?
You're right.
Okay. What is this side? L to K. Look at what they're showing you. Okay. This little section's 56. This is 88. So what's this little piece?
32.
How did you get that, CJ?
He got it from me.
56 and
No, he got it.
You did what?
I subtracted 56 and 8.
Good. If the whole piece is 88 and this little chunk of it's 56, if you subtract the two, that means from L to K is 32.
Good job.
Okay.
Still love you. I really don't.
So now that we know this, what? You didn't get that?
Oh, no, I did.
Oh, okay. I was just checking. What are you confused with?
Oh,
Talk to me. You good?
Yeah.
Okay.
Sure.
So Amelie,
Is it
now that we know how to do the left side, can you tell me what L to M is?
Right, I did it.
You didn't have to use the calculator.
Not 51.
52.
52.
Guess what? You was too slow, Charlie.
It's wrong.
Okay, so now we need to set up all of our proportions. Let me do, guys, I need your eyes up here and I need your ears open and I need your mouth shut. So,
Calculator got 51.
143 minus 91? 32 over 52. Okay, so I created my first fraction. 32 over 52 from my small figure. What do I need to do for my big figure then? Good. 88 over 143.
Don't nobody say nin.
He said, don't say nut.
Nin.
I knew somebody would say that.
Okay, 88 times 52.
Some only the calculator will know.
4,928.
Wait, hold on. Time out. How y'all get that? I got 4,576.
They don't use
Y'all robot.
Yeah, Grace. Don't. Yeah, you must have process, Charlie.
Okay,
You're right.
It's great.
I was right, Miss Smith.
Good job.
Okay. I need you to stop. It is okay to make mistakes.
Yeah, I better get off of, bro, because like y'all ain't never missed a problem. Y'all
Right.
better get off of.
So, what is, please stop talking over me.
Nah, nothing like that.
4,576.
I just said.
Okay. What is 32 times 143?
I was-
5,148. Is that correct?
Yeah, I thought
It's 4,576.
Yeah, I got
Okay.
that.
4,576.
Like, Miss Smith, bring the snacks on me.
I don't know what has gotten into you today, but you're being very rude. I need you to stop talking over me. Okay, when I talk, your mouth shut. So I'm done asking the question. So we got 4,576 for both. So that one checks out. We are not done. You cannot stop until you've said one does not work or you've checked all three. So now I need to move on and do 52 over 44, which means I need to do 143 over 121. Okay. You said 6,000 what?
292.
6,292. it works. So we've got one more that we need to check. I need to check these other two sides.
I ran out of space.
44 over 32. Careful. I did 44 over 32. 121 over 88. Okay. Please be very cautious with that because if you flip it the wrong way, it's not going to work.
3,872.
3,872.
Hold it. Hold up.
3,872.
Bruh.
Okay. So now that all three of those have worked, that means that they are similar. Okay. So you saw one side of it where it didn't work. You automatically, when you multiplied, it didn't work. We were done. When it does work, you have to continue going because just because the first two work does not mean that the last one's going to work. Okay. You have to prove it. Questions?
No, ma'am.
Okay. This one's going to glue in on page 117, my friends. And we've got 4 examples left to go on how to actually solve these now.
I understand.
Yep. It would have beat Joe.
Go ahead and trim the outside.
You may. You may trim up the second page that we're going to glue in if you would like. If you want to leave it alone, that's fine as well. It does not matter.
All right. 81.
Is this one glue in on 118?
Yes, this one will glue in on 118 when we're done.
Everywhere you go, you see somebody. Like I could just be driving and I see Will Smith.
Who is an orca?
Which is why I don't live out here.
I know. I saw.
I love you all dearly, but I would not want to live where I have to see you 24/7.
Where you said where you live at?
By my house.
She lived in like.
I live in Clemens.
Oh, cool.
It's outside of Winston.
Dang.
You got all of them.
I live on school.
And you gotta drive, boy.
Yeah. But still.
I used to drive an hour back and forth to the community college that I taught at in Pennsylvania.
Dang.
I had to walk a
That
mile.
was torture.
Left hand.
Especially when you only taught one class and it was 40 minutes long or 50 minutes long, and then you would turn around and drive an hour back.
What?
Right.
That's really what you had to do?
It depends. Monday, Wednesday, Friday, I usually taught 3 classes. So I usually taught the 11 o'clock class, the 12 o'clock class, and the 2 o'clock class. And then Tuesdays and Thursdays, I only had 1 class. So I drove out there for 50 minutes. We turn around and drive home.
That's
Did you like teaching? Oh, you like it more?
Hey, college look lit.
Pay's just not good unless you're full time.
I know, and I be thinking trips there and price potential. College be looking lit. Let him go phase, bro.
Okay. So this time, okay, they tell you that the figures are similar. We need to find the value that makes them similar. So this says you've got a 6-foot tall tent. So you've got this tent set up in your yard and the sun's beating down on it. So the tent is giving you a shadow across the ground that is 9 foot long. If the tent is next to a cardboard box, so now we've got a cardboard box sitting on the ground outside of the tent. And the box is casting a 6-foot long shadow. They want to know, how tall is your box?
Draw a picture.
Okay, so if you need the visualization, draw yourself a picture. So we've got a tent. Okay, there's your tent. Okay, your tent is 6 feet tall. And it casts out this shadow along the ground that's 9 feet long.
Oh, I did it.
Okay, I'm not the greatest artist in the world, so please don't laugh at my sad drawings. Okay. All right. Now I've got this box. Okay?
That's a cube.
What do you think a box is?
That could be a rectangle, cube.
Well, yeah, it could be a rectangular prism, but no, I decided a cubed box.
That's a special.
Okay? And the box is casting a shadow on the ground that is 6 feet long. We want to know, how tall is this box?
Did I do it?
Okay? So, just like we did with your triangles, we can set up a proportion. So, my tent is 6 feet tall and it casts a 9 feet long shadow. So, I did 6 over 9 here. What would I do for the box? This is just showing your height. That's not a number.
Oh, I thought that was one.
Okay. So I did 6 over 9 here, which means I need to do x over 6. Okay. I did the height over the length of the shadow. So I need to do the height over the length of the shadow.
This easy.
Okay. So now we cross multiply.
That's 36, 9 equals 4.
Okay. 9x equals 36.
X equals 4.
We divide by 9 and x equals 4. 4 foot. Okay. These are word problems now. 4 feet.
That's how tall I am.
Okay. You're 4 foot tall?
Yeah.
I don't believe that.
I'm pretty dang.
Nice try though.
Yeah.
I'm 6.
Okay. So now we've got a telephone booth. Although I don't even know you all know what a telephone booth is.
It is.
Okay, listen. It's that thing that Superman goes into and comes out with his costume on.
Oh, now I know.
Okay. So we've got a telephone booth and it's 8 feet tall and it casts a shadow that's 4 feet long. Find the height of a lawn gnome. Those ugly looking things that stare at you that sit out in the flower beds. They creep me out. Okay, right. Your lawn gnome that casts a 2 foot shadow. So again, if you need the visualization, draw it. So here's your telephone booth.
I'm about to dress up like Alo.
Okay, here's your telephone booth.
That didn't look weird.
And it casts a 4 feet long shadow. And your telephone booth is 8 foot tall.
Dang it.
Okay, then I've got this lawn gnome. Listen, you just let my little lawn gnome alone.
Oh, wait.
Listen.
Oh, wait.
Is that
Wait,
a-
hold on.
With the dome?
Did I have one?
Oh, shoot.
Leave my little lawn gnome alone.
Where's
I
his
like
beard?
them little
Where's his
logs,
nose?
but they scary as
They look like you, bro.
Okay, and this gives you a 2 foot long shadow. We don't know how tall your lawn gnome is. So somebody set me up a fraction with the telephone booth.
Alright, bro.
8 over 4.
Your mom.
So then x over 2, good. So if I do 8 over 4, which is the height over the shadow, I need to do height over the shadow. So when I cross multiply, I get 4x equals
X equals 4 again.
16, divide by 4, and yes, x equals 4 feet again.
Well, I was right.
You see, I ain't know I could be
You
this
just needed
smart.
to double it because in the beginning it was
Thank
half.
you.
The telephone booth is 8 feet, the shadow
Okay,
is 4 feet.
good. That's another way to look at it. Okay, so stop and listen to what I'm saying. Okay. If my shadow is 4 foot, my telephone booth is twice as long or twice as big. So if this is 2 foot, that's got to be 4. So if you can see it like that, by all means use it. If you cannot, or if they ask you to prove it, you need to show the calculation. Okay. All right, 2 more. A map. Okay, so you know that a map is a scaled down figure of the real world. I'm going to flip this for Bubba to not stop.
Real world.
You're not. I'm not referring to you. Okay, map is just a scaled down version of what's in real life. Okay, so it is a similar figure. A map has a scale. Every 3 centimeters on the map is 18 kilometers in real life. If Riverside and Smithville are 54 kilometers apart, they want to know how far apart is it on the map. So you want to create your first fraction from the scale of the map to real life. So my map is 3 centimeters. And in real life, that's equal to 18 kilometers. All they tell me for the second fraction is we're 54 kilometers apart. Where does that go? The numerator or the denominator? Denominator. Why? It's kilometers. Kilometers are in the bottom of the first one, so it has to go in the bottom of the second one.
So X goes on top.
So X goes on top. That's what we do not know.
So it's 3 times 54.
3 times 54, which is what? 162 equals 18 times
I bet you
X.
it's 4.
Divide by 18.
Why'd you do it backwards?
Hold on.
It doesn't matter. You could do it either
It's not
way.
4.
It's
not
9.
It's 9. 9 what? What should X be in?
Centimeters.
Centimeters. Centimeters was on the top. This is centimeters.
My old math teacher would yell at us if the X was on the right side. He'd be like, no, you gotta do something to change that. And he would mark your problem wrong every single time.
Okay. This time we've got model homes. Our model home is 12 centimeters wide.
12 centimeters.
Okay. If it was built with a scale that every 3 centimeters equals 4 meters in real life, then how wide is the real house?
4 meters down.
This is why
Okay.
Wait, no.
So set up your first fraction with your scale.
16 meters.
So what does that look like?
3 centimeters.
3 centimeters over 4 meters. Okay. So if I do 3 over 4, the second fraction is 12 over X.
Where?
Okay, because they give us centimeters. So if you put centimeters on the top, it has to stay on the top. So when I cross multiply, 3x equals 48. We divide by 3. X equals 16 meters. 16 meters. Questions? Okay. I need you to, if you'd like to still trim that out, if you have not done so, you may do so. You can glue it in just the way you see it. I don't care. It needs to glue in on page 118, please.